When's the completion date for it?
Okay, the completion date for the demolition will be June next year. What we are expecting is the contractor to remove the big service structure and the rotating service structure sometime in January, February next year. So there's going to be a lot of demolition between now and January next year.
Can you tell us a little bit about the pieces we take away? What's going to be preserved from the museum?
The pieces that are going to be preserved in museums, those pieces were taken already down. Artifacts and things like the screw service arms, the beam cap, those items were removed, and I think right now one of them reside at the visitor center. There were other artifacts that were identified during the process that we were going through, and those were removed before we get the structure to the contractor. Whatever is there is going to be recycled by the construction contractor.
Nothing of interest there for
we went through that process and nobody was able to identify anything that we were going to give to anybody. So that was an NASA process that took place. You know, there was a historical, study that was done on the pad, and because part of the situation is that since we got still pad A, they consider pad A to be the last pad to be the real historical pad.
Where will the recycled metal come? The recycled metal from the structure. Where will that go?
It belongs to the demolition contractor. That's part of the contract. The demolition contractor will, you know, the price for the demolition includes the recycling of the material.
Before the demolition started, was there a photo documentation of the pad?
Yes, sir. There was the historical. What was the name of the? There's an agency that takes care of that. They came and took all kind of pictures. They identify all the structure and make sure they documented everything they could, you know, for historical purposes. I don't know. I will have to find you that answer.
You may have mentioned it in the briefing. Is the deconstruction going to be piece by piece, or are we going to be at a stage where you do explosive demolition, get rid of like the done on the side?
Like
bring the tower down. Yeah, bring the tower down. How are you doing it, piece by piece?
Yeah, it's going to be piece by piece. One of the things we prohibited the contractor from doing was from using explosives. You know, because obviously we were concerned with the integrity of the pad surface and concrete. So the contractor had to remove this in pieces to preserve the integrity of the older systems that are still there.
Suppose Congress decides to authorize more shuttle missions in the next decade. Is that one pad then sufficient, you think, to support those?
Ed, you wanna answer that?
The question was, suppose Congress decides to authorize more shuttle missions for the remainder of the decade, let's say. Is that one pad, 39A, is that then sufficient to support the shuttle program?
So I think you probably need to ask the shuttle program that, but yes, right now we're doing one pad and we just have a few missions per year. So unless we're putting a lot more stationed together, I think a few a year can easily be done off of one pad.
And what's the approximate cost of the demolition?
The approximate cost of demolition right now, just the structure demolition is about $1.4 million.
Has to recoup the funds from the recycling?
No, that goes to the contractor. That's why the price from the contractor, the $1.4 million.
The flame trench will remain?
Flame trench will remain there. Basically what we're doing right now, we did install sensors at the other flame trench, and we're gathering a lot of data, environmental data, just to have it there ready for when they select the vehicle. We will be able to determine, you know, if there's some changes that will be required, not to the flame trench itself. The size of the flame trench will remain the same, but the flame deflector, you know, depending upon the vehicle that we will see, you know, we might have to modify the flame deflector. So that's what we're doing right now.
What about any renovations?
We do have in our budget to renovate all the brickwork, you know, and again, depends, you know, the authority of Congress and the budget. But yes, as our plan, we do expect to go and renovate a lot of the brick on the flame trench.
You mentioned earlier the refurb for the storage farms. Is that the first one since Apollo? I mean, was there one done between Apollo and Shuttle? And also, are you going to keep the same capacity, or are you going to try and increase the capacity?
You mean the
locks and hydrants?
Yes, those are the original vessels. Those vessels were built in 1967, I think. And this is the hydrogen one. This was the first time that was drained. We just drained it last year, and we opened the vessel, and it was in great condition. There's very little we have to do in the inside. We did added some insulation. You know, that's composed of two vessels, one outside vessel and one inner vessel. And in the middle, there's a lot of insulation. Well, we just finished that job, and we replaced, we added more insulation to the vessel just to make it perform a lot better.
So it'll stay the same size, but what about floor capacity? Will they open up quicker?
Right now, since we don't have any details about what vehicle it is, we assume that they're going to stay the same. Once they decide what vehicle is going to go from here, then we can make that analysis and decide, you know, do we need another vessel, or do we need to change the piping that goes from the vessel down to the back. So still, I don't know. We're just making sure that the vessel, we're renovating the vessel, so the vessel will last another 20 years. Making sure that that's taken care of right now.
For those who don't know me, my name is Ed Mango. I'm basically running the Space Transportation Planning Office here. Our mission right now is to put together the plan for a commercial crew. If you think about where you guys are standing right now, or at least right before this pad, you know, for the last 10 years we've had humans on board the International Space Station. It's 10 years of continuous human life outside the surface of the planet. That is amazing. It's an international opportunity for not Americans, but folks part of the International Space Station to constantly be supporting our ability to support continuous flight on board the space station. And that happened during some very sad, difficult times in the recovery of Columbia and trying to get back to return to flight. We still were able to keep humans on board the space station for that continuous 10 years. A remarkable achievement for mankind and for the United States, who's leading the ISS effort. In order to get to ISS, this pad was used a number of times, flying the shuttle to bring parts to the ISS and also to bring crews back and forth to the ISS. So Pad B has had quite the history. Before that, it was also used for Apollo and Skylab missions, so it has an unbelievable history. We don't want to just end that history there. Last year we did an Ares 1X launch right from this pad about a year ago, a year and a couple days ago. And we definitely used the lightning towers that day, because the day of launch we actually had a lightning strike very close to the pad. And because we had those towers, we were able to work through the analysis to try to go fly that day. So those towers are very helpful for the future. And that's where the history of Pad B ends today. Now, where is it going to take us in the future? I think Jose talked a little bit about how heavy lift. This pad can certainly be used for heavy lift. Commercial Crew is a program that Congress and the White House have all approved through the Authorization Act just a few weeks ago. And it provides us a structure by which we're going to go partner with commercial companies in order to go bring crews into up to low Earth orbit and into the ISS. And you say, well, we kind of do that today. Our program today also uses contractors, industry, in order to build the vehicle, in order to work with the vehicle, in order to get the vehicle on orbit, in order to keep the vehicle flying safe and get the vehicle home, in order to process the vehicle for another flight. So what we did today on the shuttle program just over at Pad A is not that different than what we're going to go do tomorrow. The difference is we're going to look for investments both from the government side as well as from the commercial side as well as from industry. Why go do that? Because today all the stuff done on the shuttle is really done for the government. What we like to do and what the government would like to do is spur a new capability to go into low Earth orbit and do other things other than just move NASA crews back and forth to the International Space Station. In order to go do that, it makes sense for the taxpayer not to have to pay the whole bill for the development. It makes more of a sense that we invest together to go make that happen. So that as time goes on, we get our missions to the International Space Station, which we'll need to continue to do, and any other NASA mission that comes up that this commercial crew capability can be used for. But also it spurs an entire industry of trying to get access to low Earth orbit. Access for people to get to a low Earth orbit, to go do other things other than the International Space Station. Someday there might be other space stations up on orbit, and we hope to have vehicles that will get us to low Earth orbit to go to those destinations. Now, I'm not speaking of that as a NASA person, I'm speaking of that as an American who would like to have more capability to do more things in space other than just the ISS. So NASA being, you can look at it as the anchor tenant, as you would look at a mall or something like that, has to go put together what does it take to go develop the capability, work with our partners to develop the capability, make sure the capability is safe enough to put our crew on board and get our crew to ISS, and then from that we can spur other business to go do other things in low Earth orbit. It's similar to how the early days of the U.S. Postal Service worked with airmail. That was fully a government organization flying government planes with government pilots doing government work to move mail from one point to the other. Over time, that was not cost effective to do it that way. And within about 5 or 10 years, an entire U.S. airmail system came about where there was contracts being let by the government to go move mail by commercial vehicles to go do that from one coast to the other coast. And you can say, well, there's already people living in those coasts, so there was a market there. In this particular case, for commercial crew, I think the market is not just moving people up and down. That is the reason why we need this spaceship and a system. But it's to go do research for medicines, research for materials, research for global environments. All of those things can be done with people on board any system that we can put up to low Earth orbit. That's the whole purpose behind commercial crew. What we're doing over the next year or so in commercial crew is to continue to spur that development and that early conceptual and preliminary design efforts that have to go on in order to bring a system to fruition to go fly a particular mission to get to low Earth orbit. NASA has been putting together what we call a Commercial Crew Development 1, which is ongoing right now and should be ending about the end of this year, early next year. We hope to continue that with what we call a Commercial Crew Development 2, which is a continuation of what we've learned from Commercial Crew Development 1, or CCDEV as we call it for short, from the first phase into the second phase. And during the second phase, we hope to look more at what does it take to put together a complete system to go fly from the surface up to a low Earth orbit capability and bring it back and bring back our crew safely to go do that. We've just put that out. We'll see how that goes over the next number of months, and we hope to award that sometime next year, in which we can hope to continue with that development. The next phase is really the phase that is the hardcore development and design and development phase. That is where the rubber meets the road. That's where you make the design decisions, development decisions. It's where you do your certification testing and your qualification testing. That is the hard part. That is very much the hard part. That's going to start after we get done with this Commercial Crew Development 2 phase. That'll be what we call our design and development phase. Of course, it needs continuing congressional and White House approval to go do that. That is NASA's plans. And as we get that approval, then we'll continue to move that forward. And then comes what I would look at as the next phase, which is really the demonstration phase. you now have a complete vehicle. You have a spacecraft that you're going to use. You have a launch vehicle you're going to use.